minus Vm cos beta first. Replace this omega t by this beta. So we have Vm cos beta minus E naught beta, and then minus minus will become plus. Put the value of alpha. So alpha plus E naught alpha. If I'm not wrong. So this would become plus, yes, E naught beta, and these two values will become E naught alpha. So how do I replace this beta from alpha? Can you replace this beta by alpha? So what is beta? Pi minus alpha. Since this beta that we can calculate pi minus alpha, so I can put this value. Now let's put this value V naught. So V naught will become 1 over 2 pi 2 Vm cos alpha plus 2 E naught alpha minus pi E naught. That is the average voltage which we have calculated across the load. Across the load means across the battery as well as across this series resistance which we have connected here. Now if I wanted to calculate the current, then suppose I wanted to calculate this current, so this expression will be 2 pi r, and rest of the expression would remain same, 2 Vm cos alpha plus 2 E naught alpha minus pi E naught, like that. Now if I wanted to calculate this VRMS, right, VRMS and average voltage, these two voltages are important while we are going for such charging system. So we have to calculate the RMS voltage of output voltage. So RMS voltage, let me write as a RMS voltage. So VRMS, that is equal to root over, again we will integrate in 1 upon 2 pi, and the limits will be alpha to beta. What we have to do, Vm sine omega t minus E naught square d omega t. That's all. Right? We have to take, in case of RMS, what we have to do? We have to take the root mean square as well as we have to take the square. So open this voltage from formula A minus B whole square. So if you open it, the result would be, I'm writing this result here directly because I have done this analysis. So Vm square by 2 plus E square pi minus 2 alpha plus Vm square by 2 into sine 2 alpha. Right? Sine 2 alpha minus 4 Vm E cos alpha. These are the two particular, expressions, or these are the three terms which we are getting, and these are the two expressions which are really important while we are calculating different values during charging and charging this battery from the source, right? In continuation with this, I will give you one hands-on problem here, and we will try to see how do we get the efficiency and other parameter, how do we calculate the efficiency in such case, how do we calculate the conduction angle for this particular thing. So here I am going to give you one hands-on problem. So everyone, please open your notebook and try to solve this problem. So in a wave rectifier with R and battery. R in battery. Just hold on, just 1 second. This is an important call which I have to. So, in a half wave rectifier with R and battery, right? A battery voltage is chosen as battery voltage is chosen as 12 volt, right? How much battery voltage we have selected here? 12 volt. Now, with its capacity of 100 watt hour, with its capacity of 100 watt hour, the average charging current, which current it is? Average charging current. Can you name this current here? Average charging current is 5 ampere. The primary input voltage 120 volt, 60 hertz. Transformer has a turn ratio of 2 is to 1. This is important. Turn ratio is 2 is to 1. Calculate number 1, conduction angle of the diode. So don't be confused. This conduction angle, it doesn't mean it is it is the angle of diode. Diode doesn't have this three it is not a three terminal device. So conduction angle of the diode. Second one, load resistance, right? Means battery internal resistance. Third one, power rating of resistance. Power rating of resistance. That is R. Now, fourth, charging time. Charging time of the battery. How much battery has taken time to get it? I mean, fully charged. Charging time of the battery. The fifth one, efficiency, rectifier efficiency. Rectifier efficiency. And the fourth one, sorry, sixth one, PIV of the diode. What is PIV of the diode? What is PIV? Those who are belongs to, yeah, peak inverse. Yes, peak inverse voltage. Inverse voltage. Try to solve it, everyone. Open your notebook and try to solve it. So we have primary winding like this. So this is VP, and then same structure which we have discussed in detail in the previous slide. Same circuit we have to draw. This is R, this is E naught. Right? Can you calculate the first one, conduction angle of the diode? Let me know all the values. Hmm? Anyone? How do we calculate the conduction angle, by the way? What are the formula which we will use? Conduction angle that can be calculated from Vm sine alpha that is equal to E naught. So alpha will become sine inverse of E naught by Vm. Right? E naught by Vm. Now can you calculate? So what is the value of E naught, by the way? 12. Yeah, what is the value of E naught? 12. Correct? Battery voltage is given already. It is given in the question. So E naught is 12. Can you calculate? I put all these values.
Yeah, alpha is equal to 8.13.
Alpha equal to 8.13. Alpha equal to 8.13. Very good. Degree. Right? It is in degree. Now next one. Load resistance. calculate the load resistance. So for calculating the load resistance, what we have to calculate? What is the value of load resistance?
4.26 resistance ohm.
Load resistance that you have calculated
26 ohm.
26. No, it is 4.26.
Yes, sir.
Yeah.
Power of rate of resistance.
Please mute yourself. Don't disturb others for this.
Sir, how to calculate the alphas? That's also I have some doubts. Sign university.
How to?
Yes.
How to calculate
The alpha?
alpha?
13. How it seems.
How do we calculate alpha? You are saying? You are asking what?
Yes, sir. Yes.
Okay, so alpha, as you can see in the screen, we have Vm sin omega t. Sin omega t, that is E naught, because the conduction will start at alpha. So at this point, E naught is equal to, battery voltage is equal to the Vm sin omega t. So that's why we have equated with this sin omega t, Vm sin omega t. What is the value of E naught? That is 12. What is the value of Vm, by the way? Vm. So Vs, that is given. VRMS is given, right? VRMS voltage, that is 120. From this, we have given 2:1 ratio. So the actual secondary voltage, that would be 1 by 2 into 120. So this is 60 volt. And so this is the RMS one. This is the RMS one. Now, if I want to calculate Vm, then Vm, so 60 into root 2, that would be the Vm. So Vm, how do we calculate? What is 60 into root 2? Let me take a calculate. So 60 multiplied by root 2. That is 84, 84.85 volt. Now take this sine inverse. E naught is 12 divided by 84.85. Calculate. How do we get this particular thing? Able to get it. How do we calculate alpha now? It is clear? Clear now?
Okay. Let me
Yeah. Now calculate the load resistance. So for calculating load resistance, what is the requirement? To calculate R. So I naught, that is V naught by R. And you can see the average charging current that is given 5 ampere. So I naught is given 5 ampere. So if you want to calculate R, we have to calculate the average voltage. Very good. So average voltage formula, what is the average voltage formula? So we can see here, we have calculated the average voltage 1 upon 2 pi 2 Vm cos alpha plus 2 E naught alpha minus pi E naught. So I can put this V naught, that is equal to V naught 1 over 2 pi R 2 Vm cos alpha plus 2 E alpha, because R we have taken here, right? So this is no more, this is I naught, right? So V naught by R, that is I naught. So 2 Vm cos alpha plus 2 E alpha minus pi E pi E E naught or E, whatever the value you can take. So can you calculate I naught now? Not I naught, sorry, because I naught is given already in the question, that is 5 ampere. So we have to calculate R. What is the value of Vm? 84.85. You can put here. What is the value of alpha? You already know now, 8.13. E naught, it is 12 volt. Alpha, you have to put in radian per second here. Try to understand. Alpha is directly multiplied with the voltage, so this will come into in radian. However, this will into radian. No, sorry, in degree. And pi is also in radian, so this way we can calculate 3.14. Can you calculate this? Try to tell me the answer. Put all these values. Can you calculate?
0.25 ohm.
5 to 5 ohm. So around not 5 to 5 ohm. So R value would be, you have to calculate, that will come around 4 ohm. That if you put all these values, try to understand alpha we have to put in radian. So how do we convert this angle into radian? 8.13, that we have to convert it into radian. You will not put in angle. Right now it is angle. So pi by 180. You have to multiply by 8.13 pi by 180. So this would be 4.26. Now let's go to the third one, power rating. Power rating of resistance.
What is the value of the 2 R value?
R I have written here, 4.26. 4.26.
Where is this has changes for 4.66?
So let me solve the other part, third part, power rating. Right? Power rating of resistance. Generally, when we are talking about the power rating, we are not taking the average power. We are talking about always the VRMS and IRMS. So in this case, we have to calculate this IRMS. PR, we can say power rating PR, that is IRMS square into R. So R already know, now need to calculate IRMS. So if you want to calculate IRMS, we have to calculate VRMS square by, VRMS divided by R. Correct? So what is this VRMS? VRMS already we have calculated from the previous one. So this is the value of VRMS. We have to put this value. Correct? So I'm writing directly here the value of VRMS divided by R, that you will get IRMS 8.21 ampere. Once you got this IRMS, you can calculate 8.1221 square multiplied by R. What is the value of R? 4.26. So what is the power rating of this resistance? 287.4 watt. 287.4 watt. Now the charging time. This is really important. Charging time. Anyone who can tell me like how much time it will take to fully charge? So watt hour we have, correct? What do you mean by watt hour? Generally, the rating of the battery, as I told you in previous cases as well, that is watt into hour. So what is the power delivered to the battery? Can you calculate power delivered to the battery? Power delivered to the battery? Voltage multiplied by current. So average current of the battery is 5 ampere. 12 volt it is going. 12 volt battery voltage is there. So this would be 60 watt. 60 watt. Now can you calculate the charging time? What is the capacity of the battery? Full capacity? Full capacity of the battery? 100 watt hour. So total capacity of the battery is 100 watt hour. We know this total capacity of the battery is 100 watt hour. How we can calculate the time? You can calculate the time, anyone? So as I told you, watt hour, and we have this wattage and hour. So we have to calculate the hours. So total capacity divided by the charging time or charging power delivered to the battery, that is 60. So 60, 100 divided by 60, how much it will take time?
1 hour 40 minutes.
Right? So 1.67 hour. Correct? This much time it will be taken by the battery to get to get it fully charged. Now next one, I hope you understood this point. Any confusion in this point? How do we calculate the hours of a particular battery when it will be fully charged? Okay, then let's move ahead. Now,
Is previous.
yeah.
Sir,
Can you calculate efficiency?
Yes.
Yeah. Calculate the efficiency. Efficiency in percentage. What is the total power delivered? out